Hey everyone, today I'll be going over a Leetcode problem. It's a medium, if it ever loads. And it's 2048, next greater numerically balanced number. This is actually in the recent most contest. Basically, you're given some n and you have to find the next number that's greater than it. That's a beautiful number. So a beautiful number is a numerically balanced number. So that means every digit has its digits occurrence. So what I mean by that is, see we have 1, 3, 3. This is actually the answer for example 2, 1000. It's the next greater one. It has 1, 1, and it has 3, 3s. So that's why it's, beautiful or whatever. So say we started at 1, 3, 3, and that's our n. We have to find the next beautiful number. So we'd actually have to go through and, find the next one that it is. So basically all we're going to do is we're going to have like some framework here. So we're going to have like some isBeautiful number function, and we're going to be doing this the brute force way. I know there's a way you can use like backtracking and like prune off different branches of that backtracking to decrease your search space, but I'll go over this and I'll talk about the time complexity. It's actually not that bad because if we look at the constraints, it's just up to 10 to the 6. It's actually really not that expensive. So anyways, with that being said, so all we're going to do is I'm just going to do while true because of those constraints, like I said. And basically, we take this, and if it is a beautiful number, all we do is return n, right? Because that's the next beautiful number. And what we want to do right here is actually do n++ first. The reason being, and you can actually move this inside of the loop like that. The reason being is because if we start off at an n, and it already is a beautiful number, we're going to get the next beautiful number. So we actually have to increment it before we pass it in. And that'll increment it each step of this loop, so it's fine. Next, what we want to do is we want to count the digit frequencies, right? So let's actually have some frequencies array, and this will be 10, because there's only 10 possible digits, 0 through 9. And then we're going to go as so long as n is greater than 0, right? So are there still digits to grab? And we can get the rightmost using the mod operator. Here's a proof of concept. You have this. If you mod it by 10, that's equal to 3, which is the rightmost number. And then we divide it by 3. We divide it by 10, which is integer division. So it'll kind of slide it over. It'll shift it over. So anyways, with that logic being said, let's actually get the rightmost number like this. And then let's increment the rightmost number, ++, and have its frequency. And then all we're going to do is slide over the number, right? So shift it over. And that's really all we need to do. Now we just have to make sure that every digit matches its frequency. So we're going to just simply go for I is equal to 1, I is less than, or actually let's start off at 0 here. And also no zeros are allowed in this string. The reason being is if you have any 0, it's automatically wrong because basically you can't have 1 0, you can't have 2 zeros, you have to have 0 0. So if we see a 0 in the number or whatever, then you know that it's wrong. So I'm just going to stop it right here. So if rightmost is equal to 0, let's just return false right away. So that way from here I can just start at 1 and basically go through freq.length, which is just 10 always. And then we want to check if it digit matches its frequency. So we also want to check if frequency.i is not equal to 0, and also frequency at I is equal to I. The reason why we check not equal to 0, because it's actually fine if there is none. See this 1, 3, 3, for example? There are 0 4s in here, and that's perfectly fine. So it's just of the ones that we've seen. And that's why we have to do the not equals to 0 thing. We return false right away. And wait, hold on. Let's actually go not equal to I, because that would mean it's not equal to its occurrence. And then if we get down here, let's return true, because that means everything's fine. Let's actually run this code. It should be good. And looks like it's pretty good. Let's go ahead and submit this. And I did it because I had just done it in the contest yesterday. 50%, 60%, not bad, because like I said, this is brute force, but it's actually not that expensive. And we'll talk about time complexity here. So time is on the order of O n log n, and I'll explain why it's n log n actually. So n is simply because we're iterating like n times until we find the next one, and it's really just like the distance between the next beautiful number and the current number, but we'll call it n because it's bounded to n. And because we're iterating n times, the log n part is because we're actually doing while loops for each single digit. Or, each single number. And we actually have to go through each digit in that number. So it's log n on this while loop because we're actually dividing by 10 every single time. So really it's on the order of n log n because, you know, we do one loop on the outside and then we do an inner loop on the inside, and that's actually just going through each digit and it's dividing by 10. So it's n log n. Space is constant because the only space we really use in this entire problem is like this frequency array, and it's bounded to 10 always because that's how many digits there are. So constant space and log n time. So yeah, hope this made sense. Thank you for watching.